Sorry, it appears my mic was not on. Hey, my name's Eli Kilgore, and this is my Physics 2211 Lab 1 on constant velocity. Here's an introduction to lab. First, we measured the position of a marker rolling across a whiteboard using a meter stick, a camera, and a measurement we drew on the whiteboard. Then we compared it to an object with constant velocity on glow script by calculating the initial and final position over time. Newton's second law played the biggest role in this lab. The system includes the marker, the hand that pushed the marker, and the whiteboard that the marker was rolling on. There are many factors in this lab that cause the real-life experiment to not travel at constant velocity. The fundamental principles in this lab were first the velocity update formula, then the net force is equal to 0, and velocity final is equal to velocity initial because the net force is 0. Here's an image of the program tracker we used to demonstrate the position over time observed with this marker.
Clan war incoming, Tyler.
Here's a larger image of the graph shown in tracker that demonstrates the position in meters over the time in seconds of this marker on the whiteboard. Here's the glow script model we used with the computed velocity over time that demonstrates a linear path, and then on glow script I adjusted the net force, the position of the ball, and the velocity of the ball by changing the net force to 0, the position of the ball to the initial starting position, and then the velocity of the ball to the final position minus the initial position over time. On this graph shown is the observed and computed positions versus time. The observed position is the position that was tracked on the tracker program, demonstrating the exact position over time, while the computed position was calculated and has a linear path the entire way. As you can see, the observed position is not fully linear because of the fact that tracker is not completely accurate, and there are also some real life scenarios that cause the net force to not actually be equal to 0. If the positive x and negative x axis were interchanged, the marker would be moving in the negative x direction with negative velocity, but still be at the origin, because the only thing that would be changed is the axes would be flipped. If the net force is equal to 0, then the opposing force on the ball is equal to the driving force. Therefore, the marker will have a constant velocity over the entirety of its path. Some experimental errors shown in this lab were, first off, the friction of the floor, the surface that the marker was rolling on caused the marker to slow down over time, as well as there was some air resistance that was slowing down the marker. And then the tracker software is not entirely accurate. There could have been some user error, as well as I personally graphed the position by clicking the center mass of the marker over time. And then, speaking of the center of mass, another experimental error could be uneven weight distribution, because the marker has an abnormal shape, and the cap and the body of the marker could cause the weight to be unevenly distributed, which could lead to an offset center of mass and an abnormal travel path for this marker. Thank you for watching. Here on this slide, I showed an image of fireworks because I personally really enjoy fireworks, and I hope you do as well. So thank you for watching my Physics 2211 lab on constant velocity, and this is Eli Kilgore signing out. Have a good night.